I'm Sebastian St. James. Today I will reveal what could send you broke in retirement and why 2,035,812 Australians will go broke. The number one recommended way of retiring is the 4% rule. What is the 4% rule and how can it help you save for retirement? The 4% rule for retirement spending makes a comeback. The 4% rule states that you can comfortably withdraw 4% of your total investments in your first year of retirement and adjust that amount for inflation for every subsequent year without risking running out of money for at least 30 years. That sounds amazing! You automatically keep your withdrawals up with inflation and it's been thoroughly tested, so there's no chance of you running out of money at all for at least 30 years. Except that is not true. If you retire using the 4% rule, there is a real chance you will run out of money. With the 4% rule, can it send me broke? The answer is yes. Is it too risky for some people? The answer is yes. Should I be worried? Well, possibly. It depends on how high the risk of you going broke actually is. Are there safer retirement methods? The answer is yes. If the 4% rule can ruin your retirement, well, why would anybody in their right mind actually use it? Well, the answer is, for some people, it's exactly the right method. This is Heidi, and she's one of my channel members. Heidi works as a teacher and her paycheck comes in like clockwork. Since she actually graduated teaching college, she's never once been out of work. Heidi's expectation is that retirement withdrawals must keep pace with inflation. And she's not willing to live off a varying income. And so for Heidi, the 4% rule is probably perfect. With the 4% rule, you retire with 60% stocks and 40% bonds. Why specifically 60-40 rather than 50-50 or 70-30? This is William Bengen, the inventor of the 4% rule. Bengen used a 60-40 portfolio model, 60% equities and 40% bonds. So because that's what his theory was based on, it tends to be what people use. In year one, you withdraw 4% of your total balance. In the second and subsequent years, you increase your withdrawals by inflation. And then you rebalance your 60-40 portfolio every year so it retains that same ratio. And that's all there is to it. No wonder it's such an attractive method. Your money coming in, your withdrawals are guaranteed to keep up with inflation because you up your amount deliberately to keep up with inflation, and always you've got that money there coming in to pay the bills. But that's not the end of the story. Oh, I just got a thanks from Elmo. Your efforts do not go unnoticed. I wish you good health and success. Wow, thank you very much, Elmo. That I really appreciate. I'm glad you're wishing me good health because I had an emergency visit to my doctor today. Elmo and I must have a psychic bond. Hopefully I'm going to be okay in the next couple of days. I mean, I feel well enough to record this video, but that emergency did happen. This is Kwong, and he's one of my channel members. Kwong is a chef. His expectation, don't go broke in retirement. Oh, that's a very good idea. And he's willing to accept slight variations in his income. The 4% rule is a terrible idea for Kwong because it has one fatal flaw. With the 4% rule, withdrawals keep up with inflation. Tick. Even if that sends you broke. Oh. Hang on, Sebastian. Tell me about the going broke bit. In a high inflation, low growth period, there is a real risk your balance will go to zero. In other words, totally broke. The question is, how likely is that to happen? If the risk of going broke is 20%, look, I'm out of here. That's not acceptable. On the other hand, if it's only 0.01%, well, yep, that's probably okay. Stop everything, Sebastian. I need to know exactly what this risk is. Can you use your special superpowers to somehow calculate this risk so I know exactly what the probability of me going broke in retirement is if I use the 4% rule? Yes, I can, and precisely to 1 decimal place. Woo! But to do that, I've been collecting a lot more data. Just 2 videos ago, the S&P 500 plus dividends, which is the S&P 500 total returns, converted to Australian dollars, we had 43.5 years of data. After my collection efforts, we now have 54 years. Wow, okay. 2 videos ago, with bonds, we had 10.4 years. Now, we have 54 years. Wow, that is 5 times as much data. And with Australian inflation, I have 73.7 years of it. That amount of data is massive. But how do we use all that data to figure out the failure rate of the 4% rule? We randomly sample the accurate historical data using a cryptographically secure method. Cryptographically secure? That's new. What does that even mean? In a programming language, if you use the random function, you get pseudo-random numbers. They're not real random numbers, they're worked out by an algorithm, and for a lot of cases they're good enough, but they are in fact repeatable. There's not true randomness. With cryptographically secure random functions, they gather entropy, that means randomness, from various environmental sources, such as network traffic, mouse movements, or keyboard inputs. The computer maintains a source of randomness of what actual humans are doing. Yes, I know, it's pretty amazing. And their unpredictability, which could never be replicated in an actual computer program, is used to introduce true randomness. What this means, by using this method, I could run my simulation 1,000,000 times and always get entirely different results. So, with the 4% rule, we'll be fully simulating 30 years of it, with 60% stocks and 40% bonds, with yearly portfolio rebalancing, and with that initial 4% increased by inflation each year. Right now, let's run the first simulation of the 4% rule. And here it is. This shows you your balance, so your stocks and bonds combined, at every point over an entire 30 years. Good, we have one simulation. Now what do we do next? We run multiple 30-year simulations to calculate the probability of success or failure. Perhaps our simulations will go like this. Pass, 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 pass. Oh, passes across the board. Or it could go like this. Pass, 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 fail. Oh. So it failed 25% of the time. For the simulation, we sample historically accurate data in 1-year chunks. Now, I don't mean actual calendar years like 1964, 1972 and 1954. But what we do is pick completely random dates out of our entire data set and take a 1-year chunk from that exact date. And importantly, stock returns, bond returns and inflation are sampled using exactly the same dates. If in real life, bond yields tend to go up with inflation, and that's probably true, then because we're sampling everything at the same date, any inherent connection between, say, bonds and inflation will be present in our samples. But taking samples introduces a potential problem. Here's the S&P 500 total return over 1 year. Total return includes the dividends. I can take the price at the beginning of the year and the price 1 year later, and job done. I've calculated the return over that 1-year period. But when the RBA governor gives out inflation data, the consumer price index, the CPI, is a quarterly measure of inflation. Oh. Here is a graph showing you the Australian CPI over 1 year. Unlike the stock graph I showed you before, I can't really directly sample this. If I sampled the difference between inflation at the beginning and the end of the 1 year, I'm going to entirely miss out on what actually happened between those 2 points. And so I have created a brand new index. We take a hypothetical $1,000 and increase it by CPI along the way. So if CPI shoots up in the year, so will my $1,000. It's exactly like investing in a bank, except we're using CPI as our interest rate. And here it is. I'm calling it Australian inflation. It comes directly from the raw CPI numbers, and it converts the CPI into a continuous return graph that reflects the rate of CPI and how long those rates were held for. So now I can take the beginning and end numbers, subtract them, and that will tell me the true difference of inflation over the 1-year period. The time has come to make many runs of the 4% rule and to find out how many fail, if any. Maybe none of them fail. And by failure, I mean you have $0 left. You're totally out of money. So what happens in the simulation if we run out of money? Well, unfortunately, like real life, you still have bills to pay. I've completely run out of money for the week. How dare they send me an electricity bill? That's not how it works. The bills still keep coming in, and so with the simulation, we keep deducting money below zero. In other words, we take out a loan so we can still afford to pay our bills and live. In the 4% rule, this is very straightforward. You have your 60-40 portfolio, which potentially can go broke, but separately and unrelated is the amount that you withdraw. You start off with 4% of your assets, and then you increase it by inflation each year. So that figure, your withdrawal amount, is kept entirely separate from your actual assets. So you can go broke here, but your withdrawals keep going up. Is this related to sequence of return risks that Elmo wants to know about? Yes, this is entirely related to sequence of return risks. And that asks, what is the chance that a retirement plan that works on average will fail for me due to early returns being poor? In the next video on this channel, we will go more into depth on sequence of return risk, but this video will calculate the sequence of return risk for the 4% rule. Today, we'll calculate how likely the 4% rule is to fail, but how useful that answer is depends on how many simulations we make. We call that measurement resolution, and it works like this. If I did 100 runs, 100 simulations, if one of those failed, well, that's 1 out of 100, so it's a 1% failure rate. If 2 failed, that's a 2% failure rate. 3 would give me 3%, so my measurement resolution is down to 1%. On the other hand, if I only did 10 runs, if 1 out of 10 failed, well, that will give me 10%. 2 would give me 20% failure rate, 3 would give me 30%, aha! So the measurement resolution is 10%. The time has come to answer the question once and for all. If I retire using the 4% rule, how likely am I, if at all, to go 100% broke? It's time for you to guess. The failure rate of the 4% rule is, well, what? I don't know. This is your guess. Lock in your answer now. Now you're all locked in, release the simulations! Will these be Monte Carlo simulations, Sebastian? Yes, and we'll be using Market Simulator 2.5, which I've only just recently created and introduced in the last video. The simulations have begun. Here's the actual data of some simulated runs. Well, okay, that's interesting. Firstly, I noticed this is in fact the 4% rule, so we've definitely got the right data set. And there is a simulated date, which I notice are dates into the future. Interesting. And the last column is the total balance of your portfolio down to many different decimal places. Wow, okay, that's how accurate my simulations are. At each date, we only had one entry, which you call balance, but the 4% rule has way more information than that. It has the 60% stocks, the 40% bonds. It has our withdrawals, which keep going up with inflation. That information wasn't there. How is that actually stored? Market Simulator 2.5 is a massive program, and we do one run at a time. An entire 30 years, we record the results for that, we reset everything, do the next run. So each run is completely separate. And those figures, which is the amount of stocks, bonds, inflation, and your withdrawal percentages, are actually kept in the computer's memory in the simulation. And what we do, we only write out the total to the database, but of course, everything, every nuance you can possibly imagine is being fully simulated in the computer's memory. Which gives you a graph like this, where we show the total at each point right across 30 years. Plus, there's a run number in the database. The entire data set for that run is stored against that run number. Oh, I just got some thanks from Elmo. Thank you very much, Elmo. I really appreciate that. And I've noticed that Elmo has discovered that dividends are missing. I must watch that video and find out where they've gone. Given that the data is against individual run numbers in our database, could I hypothetically extract all the data for one individual run of my choice? Well, the answer is yes. Here, for example, is run number 1. That's a complete simulation for just that run. Let's have a look at the raw data. We start off with $768,000. That figure comes from here. In our actual simulation, we start off with $800,000. It's an amount I chose that would be suitable for this. In year 1, we withdraw 4% of that, which is $32,000, which means the total after the withdrawal in our first entry is $768,000. So that result goes in the database. Here, I've extracted run number 10. Oh, good. So we now know we have 10 simulated runs, which means our measurement resolution is 10%. Actually, it's slightly higher, because the first run is run 0. Oh, that means there's 11 runs. 11 runs is good, but are there more? Oh, run number 99. Wow, that means we've got 100 runs. Meaning our measurement resolution is now down to 1%. Okay, that is impressive. This means I can now tell you whether the failure rate of the 4% rule is 2%, 3%, 11%, down to the closest 1%. And here is the graph of those 100 simulations. Wow, impressive. The question is, which I'm trying to tell from this graph, did any of those simulations actually go broke? Maybe, but I can't really tell from that graph. Oh, I just got a thanks from Alan. Thank you very much, Alan. That was very nice of you. Now it's time to take the simulations even further. Here is the 500th simulation. Wow, okay, I didn't think there was that many atoms in the universe. This means our measurement resolution is now 0.5%. Woo! Here's a graph showing just 100 simulations. We've now got 5 times as many. Oh, I just got a thanks. Thank you very much, Phil. Phil has now been rocketing up my question queue and he's now in position number 4. Oh. And here it is, the big reveal. How many full simulations of the 4% rule did I actually do? Let me zoom in. Oh, the total runs was 1,000. Whoa! Which takes our measurement resolution to 0.1%. That is incredibly accurate. This means I can accurately say that the failure rate is 3.4%, 6.9%, or 0.1%, down to 1 decimal place. So far, we've seen 0 failures. Hooray! This means the failure rate of the 4% rule is 0%. Is that right? Or are you holding something back from me, Sebastian? Well, let me put it to you this way. I told you that our runs started at 0 and then counted up 1, 2, 3. And in computer science, that's not unusual. Now, I showed you the graph of run number 1, but of course, that's not our first run. Run 0 is, but I mysteriously left out what run 0 looked like. Was that an oversight? No. So I shall reveal for the first time what run 0 actually looks like. And uh-oh, we went broke. Oh dear. Oh, I just got some thanks from Elmo. Thank you very much, Elmo. Elmo is the #1 supporter of this channel and is practically perfect in every way. I've heard even sunflowers turn their heads to face Elmo when he walks past. We have seen that the 4% rule can fail, but let me make it very clear what took place here. We retired with $800,000. We withdrew only what was necessary to keep up with inflation. We lost 100% of our retirement money. We went totally broke. And then we took out a loan for $1.25 million to pay everyday bills for the rest of those 30 years. So, can the 4% rule fail? Yes, the proof is right in front of you. So far, the 4% rule has a failure rate of, well, 1 out of 1,000 runs, which is 0.1%. Maybe that's a once off, which wouldn't be so bad actually. But is it? I decided to go looking. Here is run number 201. It went broke after 17 years, and we took out a $5.2 million loan to pay the bills. Wow, that is incredible. I can see the graph, yeah, it's basically gone straight down. Here's another one, run 887. It went broke after 15 years, and we took out a $3.7 million loan to pay all the bills. So far, 3 out of 1,000 have failed, which is a failure rate of 0.3%. So, here is the big reveal. Out of our 1,000 runs, how many actually failed? Therefore, we can work out what the failure rate of the 4% rule is, and then if you choose to use the 4% rule in your retirement, you can work out how likely it is for you to go broke and potentially even need to take out a loan. Out of 1,000 runs, 77 went broke, which means our failure rate is 7.7%. Woo! 1,000 simulated runs is a huge figure. Often when Monte Carlo simulations are run, there are only 100, 125 runs. This is 1,000, so it's about as accurate as you're going to get, and it's accurate to 1 decimal place. Oh, I just got a thanks, and this one requires a fanfare. thanks. Awesome channel. Wow, very nice. Thank you very much, TC. We have discovered that the failure rate of the 4% rule is 7.7%. Very interesting, Sebastian, but perhaps this data is based on some freakish events from history when women weren't allowed to vote and the plague wiped out half of the population. No, all this data is actually data taken from within my lifetime, so every single day of it is highly relevant. In Australia right now, there are 26 million people. All Australians will retire in the future, or they're already retired. If Australians retired using the 4% rule, which has a failure rate of 7.7%, 2,035,812 people would actually go broke in retirement. Whoa! That is a chilling figure, and whether a failure rate of 7.7% is acceptable is entirely up to you. It's one of those things that you have to make based on your risk tolerance. Some people, like Heidi, have an expectation that their retirement withdrawals must keep pace with inflation. Other people like Kwong are saying, well, look, that would be nice, but I don't want to go broke in the process. Oh, I just got a thanks from David. Very nice, David. Thank you very much. The question is, if I've decided that the risk of 7.7% failure is too high for me and I don't want to go down that route, is there an alternative which doesn't have that same level of risk in it? The answer is yes, and we'll cover that in the next video on this channel. In the meantime, exactly how can the S&P 500 make you rich? Oh, click here to find out, or if you've seen that, click here.